2.4, we're going to learn about angles. So we're actually trying to figure out the measure of an angle. The measure of the angle is the difference between the direction of its two rays. So it's how far apart its rays are from one another. The unit we use to measure angles is the degree. And the measure of an angle is always between 0 and 180 degrees. So if you were to make up 3 angle measures, an angle measure could be 60, it could be 42, or it could be 112. Those are all possibilities. All right, an angle that measures between 0 and 90 is called an acute angle. Easiest way to remember it is it's a cute little angle. If you have an angle that measures between 90 and 180, it is called a obtuse angle. And the last type of angle, an angle which measures exactly 90 degrees, is drawn with a special symbol and is called a right angle. So if I were to sketch an acute angle would be a really small one. It would look like this. A right angle is going to be like this, where there's 90 degrees here. And an obtuse angle is going to be really big. So this would be an obtuse angle. So I'm going to label those for you. This is acute, right, and obtuse. If I were to have 2 angles that were next to each other and shared a vertex, for example, like this, we'll call this angle A and this angle B, those would be considered adjacent, ADJ, ACENT, adjacent angles. The definition of an adjacent angle is that they share a common side. So they share a common side. I'm going to color that in pink. And they have a common vertex. I'm going to color that in blue. And that's true of both of these angles. They had a side in common and they had a vertex in common. So they've given us 2 adjacent angles. They say AVC and BVC are adjacent. So I'm going to draw a picture. So I'm going to label this as A, V, and then C is going to be in here. And BVC is going to be here. They're adjacent. So they tell us AVC is 20 and BVC is 45. And the question asks us, what is AVB? So all it wants to know is, how big is this whole thing? Well, if part of it's 20 and the other part's 45, then to find the whole thing, all I have to do is add 20 plus 45. 20 plus 45 is 65. So AVB would be 65 degrees. Giving us another one, they say AVC and BVC are adjacent angles. So again, I'm going to draw this picture here. So here's A, here's B, here's C, and here's V. V is for the vertex. So they tell us that AVB is 72. This time they've given us the entire thing. The whole thing is 72 degrees. And they've told us that AVC, so this part of it, is 15. And the question says, what's the other part of it? So in order to find that, I can't add them together because I have the whole and I have a part. So this time I have to subtract. So I'm going to do 72 minus 15, which is going to give me 57. So BVC is 57 degrees. Connecting this back to algebra, so we're going to have to do a little bit of math here. We have, again, AVC and BVC. So AVC, and here's B. They tell us that AVC is 2x plus 2, and BVC is 4x minus 7, and we know that the whole thing, all of this, is 103 degrees. So we're supposed to solve for x. Well, what I know is that this part, 2x plus 2, and this part, 4x minus 7, makes up the whole thing. And the whole thing is also 103, so all I have to do to figure this out is solve. 2x plus 2 plus 4x minus 7 equals 103. So that means I need to get x's on one side, my numbers on the other. Before I do that, I'm actually going to combine my like terms. My like terms are, in this case, 2x and 4x because they both have x, and then plus 2 and minus 7 because they're both numbers. 2x plus 4x is 6x, and a positive 2 minus 7 is negative 5, and that's going to equal 103. So to get x by itself, I'm going to add 5 to both sides, and I get that 6x equals 108. And then to get x by itself, I'm going to divide both sides by 6. And when I divide 108 by 6, I get 18. So x is 18. I'm supposed to find AVC. Well, AVC is 2x, which is 18, plus 2. That's going to give me 38. And to find BVC, I'm going to do 4 times 18 minus 7. And that's going to give me 65. And if you were to add 38 and 65, you would in fact get 103. So if you were to have a ray that divides an angle in half, that ray is called an angle bisector. So it'd be like having everything we've had before, but it would be specific in that when that middle angle was drawn, it splits it in half. So if I have, it told me that ray VM is the bisector of AVB. So I have A, VB, and the bisector, VM. So we know that it is split in half. So AVM, they tell us, is 25. It wants to know what's AVB. Well, if VM, the green line, splits it in half, then if the top half is 25, the bottom half is 25, that makes the whole thing 50. So an angle bisector divides an angle in half. All right, two adjacent angles whose measures add up to 180 are what we call a linear pair. Okay, they're a linear pair. I'm going to give you a picture of a linear pair. What a linear pair looks like would be this, where this side is a straight line and it has one ray shooting off of it. Because it's a straight line, that makes it add up to 180, and it just has a special name, okay? And that's a linear pair. So we have AVC and BVC form a linear pair. If AVC equals 26, what is the measure of BVC? So I'm looking for this part here. Well, I know that altogether it should be 180 degrees. So to find that missing part, I can do 180 minus 26, and that's going to give me 154. So BVC would have to be 154 degrees. I would make a note of this, and this actually is going to come up in just a second, but I want you to go ahead and write this down while we're here. If two things are a linear pair, it also means that they are supplementary. They are supplementary. Okay? They are supplementary. So linear pair means they're supplementary. All right. Complementary angles have measures that add up to 90 degrees, while supplementary angles have measures that add up to 180. And people always have trouble remembering what supplementary and complementary add up to. So someone taught me this one time and it really made a lot of sense. If you think about the word complementary, you can take the C in complementary and turn it into a 9 for 90. If you think about the word supplementary, you can take the S in supplementary and turn it into an 8 for 180. So for questions 1 through 3, you're supposed to determine if the angle is acute, obtuse, or right. So remember, acute meant it was less than 90. Obtuse meant between 90 and 180. And right meant exactly 90. So number 1 is a right angle because it's exactly 90 degrees. Number 3 is 170, and that's between 90 and 180, so that would make this obtuse. Number 5 says, what is the measure of XVZ? If you're not sure what they're asking for, connect those letters together. So here's X, here's V, and here's Z. So that tells us they're asking for the entire thing. So to find it, I'm going to do 42 plus 59, and I'm going to get 101. So XVZ, angle XVZ is 101 degrees. For 6, 7, and 8, I'm supposed to determine if the pair is complementary, supplementary, or neither. So complementary, remember, when you add them, you get 90. When supplementary means you add them and you get 180. So for 7, I'm going to do 32 plus 25. If I add 32 and 25, that's going to give me 57 degrees. Well, that is not supplementary or complementary, so number 7, the answer would be neither. And the last thing, number 9, says, does AX bisect BAC? Why or why not? So looking at the next picture, and you may or may not have this picture, but if you do, that's good. If not, then you can just look at this. Well, it wants to know if this piece bisects. Remember, to bisect means to split in half. If they're in half, then both parts are equal. So the question is, did AX bisect? Did it split this big part in half? Well, if it did, then what would happen would this part and this part would be the same size. And they are not the same size. So this is no. And then if I look at my other one, when I notice that this angle is 60 and this angle is 60, since they are equal measures, that means that it is a bisector. So the answer to this one is yes. Remember, to bisect means to split in half so that both parts are equal.